So 3.3 polynomial identities. We're using some of the rules to make our life a little easier. Okay, so we have some things, we have some rules. I will let you have time. Let me talk, and then I'll give you time to write. I'll pause the video and give you time to write. So the first one is difference of squares, that a squared minus b squared. You've done that over and over and over again, right? So it's the square root of a squared, square root of b squared. Okay? The sum of squares, square of the sum. So I have a quantity and I square it. Remember, that means a plus b times a plus b and multiply it out. Okay? The rule is always you square the first. See that? You square the second. And you multiply the two together times 2 for the middle. If you learn that rule, you don't have to FOIL it out. You don't have to distribute it out. You just do it. Okay? Then I have difference of cubes. So it's a cubed minus b cubed. You take the cube root of each, the same sign. And then this becomes what you're going to use. You square the first. You multiply the two together. Change the sign. And then square the last. Every time. The sum of cubes, same thing. Same procedure exactly. Same sign, different sign. I hate that they actually write it as two different ones. When I write it myself, I do this. I do plus, minus, and then plus, minus, and minus, plus. Meaning if it's a plus here, it's a minus. If it's a minus, it's a plus. I write one rule and write sum / difference. Because it's the same rule, isn't it? It just changes the sign. So I will give you time to write the difference of squares, and then we'll do the example, and then I'll give you time to write the other one. So as soon as you're done writing the difference of squares, tell me, and then we'll do the example. Okay, so the example we're going to do is you look at a problem and it says to factor it. Well, it's two terms, so when you factor something with two terms, you factor out what they have alike and all that kind of stuff, if it's possible. But I noticed that 25 is a perfect square and 36 is a perfect square, correct? Mm-hmm. Is x squared a perfect square? Mm-hmm. Is y squared a perfect square? Yes. Now, side note, guys, is y to the 6th the perfect square? Yes, any even power is a perfect square because that is y cubed times y cubed, isn't it? So any even is a perfect square. So all it says is I go here, here, and what's the square root of 25x squared? 5x. So I put 5x in the front of both quantities. What is the square root of 36y squared? 6y and 6y, and one is a positive and one is a negative. Guys, those are conjugates of each other. Remember last chapter when we did the complex conjugates? Those are conjugates. When I multiply them together, there is no middle term, is there? Nope, and there never will be. So if you see this like this, you should be able to factor it really quick, shouldn't you? Mm-hmm. What if you saw this? Should you be able to multiply it really quick? Mm-hmm. Yes. So knowing those, it's not necessary I know all these rules, except for the cubic one, I got to know it. But will it make my life easier? Yes, that's the whole point of this section. Okay, write sum of cubes.
square of a sum?
Yeah, square the sums. Yep, that's what. I never called by a name. It's weird. Square the sums. Guys, it works for the square the differences too. What do you think the sign is in the middle? Anybody? What if I wrote the sum or difference? So if it's plus minus over here, it's plus minus, and they're both plus. So like if you had a minus b squared, it would be a squared minus 2ab plus b squared. Basically same rule, right? Oh, well. I kind of made my C and E. See it? I made it all in one. Okay, you guys ready to go to the example? No one's yelling. Okay, so I have x squared plus y squared squared. Not squared. 3x plus 4y squared. Yes? Now, that does mean I do 3x plus 4y times 3x plus 4y if I don't remember the rule. Yes? Okay, so if I do remember the rule, I square the first, which is what? 9x squared. I multiply 4 times 3. So it's 12. And then I multiply that times 2. So 24. And you have an x and a y. And then you square the last.
60.
Y squared. Now, over and over and over, I see you guys doing this. When I tell you, when I give you this problem, I will get this almost every single time. Is that right? No. Exponents do not distribute over addition. You can't do it. It means to FOIL it or distribute it or whatever you want to say. Now, if I had 3x times 4y all squared. Could I do that? Yes, because it's multiplication. I don't know why you wouldn't put 12, but you know. Okay. Write the sum and difference of cubes. Don't write it separately. Write it as one. So write sum / difference of cubes and give yourself a plus minus. And then this one would be a plus, minus, and this one would be a minus plus. Let me write the signs not over the black. That's kind of confusing, isn't it? Then you don't have to write it twice. It's always helpful, isn't it? Okay, you got your example written down? So 8m cubed minus 27. So you see this problem on your paper and it says find the solutions or solve. Okay, so solve means to factor. If it says find the x-intercepts, it means to factor, right? So all those things need to factor. I look at it and I'm like, well, m cube is the first thing that's going to throw me that it's a cube, yes? So then is 8 a cube, a perfect cube? 2, right? Is 27 a perfect cube? Yes. Okay, so what we do is we take the cube root of the first thing. So what's the cube root of 8? 2. What's the cube root of m cubed? M. Same sign. And the cube root of 27 is 3. So now that we have that, we are ready to just go on to our next thing. We don't use the original anymore. You go square the first thing. So 4m squared. Opposite sign. Plus. Multiply these two together. 6m. Always plus. Square the last. Because -3 times -3 is 9. So it's always addition on the end. Because a negative times a negative is a positive. So, and I'm going to tell you a secret. When you do these, the only real solution comes from here. This would be m equals 3/2, wouldn't it? Can I get the factors of 9? Oh, the factors of 36 to add to 6? No, I can't get the factors of 36 to add to 6. It doesn't work. So you could do the quadratic formula, but you're going to have a negative answer, so it's not a real solution. Okay? So let's do the sum one down here. So 8g cubed plus 64h cubed. So what cues me off on this problem to look for if they're perfect cubes? The g cubed and the h cubed, right? So is 8 a perfect cube? Is 64 a perfect cube? Yep. Okay, so we're going to do it. So the cube root of 8g cubed. 2g. Same sign. The cube root of 64 h cubed. 4h. And now I'm only looking at my first and second thing. So you square the first. So 4g squared. Opposite sign. Minus. Multiply the two together. So g is negative 8gh. Always plus, and square the last. So 16 squared. And there's your answer. Oh.
Well, that's not that hard.
No, it's not hard at all, but you have to remember it. Yeah. It's just little things like that. Okay, so these are special factoring that will help you. They'll help you save yourself time. Okay? So now these we have examples. And Pascal's triangle is tomorrow, right? So I have his examples for you. Okay. So use your identities to make this easier for you. So I have 2x squared plus y cubed squared. Okay, so what is my rule? What does your rule tell you to do on this? That's your square of the sum, right? What does it tell me to do? Square the first term. So what is 2x squared squared?
4x.
To the fourth? Okay. Then it tells me to do what? You do these two, you multiply them together, and then you multiply it by what? 2? So 2 times 1 is 4. X squared y cubed. And then what? Square the last one, so it's going to be plus y to the, yep, and that's it. So if you want to write it out longhand, it is 2x squared squared plus 2 times 2x squared y cubed plus y cubed squared. Isn't that what we did? Okay.
Do we have to write in order? Like 4x to the fourth,
Yes.
y third, and then
Yes.
y.
Yep. Okay. I don't want to do this one because I took it off from you. I don't want to do it. I don't like it. I'll do it. Okay, so we're going to change this to look like a problem like this. Okay.
That sounds really hard.
Well, I forgot how to do it. I don't have any of those problems for you in your homework. I took them out because I think it's useless. Well, I'll tell you what I would do, but you don't need to write it. If I were to multiply these two together, would you guys not do like 40? Like if I did 40 minus 1, sorry, 40 plus 1 times 40 minus 1 is 40 plus 1, 41.
Yes.
Is 40 minus 1, 39.
Yes.
Okay, didn't I just give you conjugates right there?
Yes.
Yeah. So when I would do that, that means I would square the first, which would be 1,600. Yes? Minus, you square the last, which would be 1. So the answer would be 1,599.
That's kind of pointless.
Well, it works awesome, yeah. That was so much quicker than doing 41 times 39, but are you going to remember it? No. You're not. So, but it works. But I didn't assign you any of them because you're not going to remember it.
So if I somehow see that on another test, do I just multiply it?
What?
If I see that or something like that,
Uh-huh.
I just multiply.
Yeah.
All right.
Yeah, that's it. I mean, like, let me see what another, like, if you had 65 times 63. So what's the number in between 65 and 63?
64.
64. So it'd be 64 plus 1 and 64 minus 1. But I wouldn't know 61 squared, would you? Or 64 squared. So I took all those problems out of your homework. You'll see them in the book, but I didn't assign them into you. Okay, let's go to the bottom one. Next one. 3x squared plus 5y cubed times 3x squared minus 5y cubed. What do you got there? Those are conjugates, right? If they're conjugates, what's going to happen to the middle term every single time when you multiply it out? 0, isn't it? So do you need to multiply it out? You need to square the first term and square the last term, and there's going to be a negative in between them, right? So what is 3x squared squared? 9x to the 4th minus 25y to the 6th. Now, that was something that would save me a lot of time, right? Guess I don't need those parentheses, do I? So if I saw this, could you go this way easily? Should you be able to go that way easily? Yes? It is something that can help me factor and multiply, can't it? Okay, so this is the other one. That's the 12 plus 15 squared. We'll do it, but you don't have any in your assignment. So the rule is square the first, correct? So it is 144. Multiply the two together. So this is where it's like, I don't even, well, we could multiply 15 by 2, couldn't we? Because it's 2 times 12 times 15. Well, 2 times 15 would be 30, wouldn't it? And 3 times 12 is 36, so that'd be 360. And then 15 squared is 225, which you should know. So if I add that all up, I get what? 9, 12, 429. That sounds weird. Oh, no, I forgot the 2. I forgot the 2. I forgot to carry. Like, I forgot there's 3, 6, 7. It's like, that is not right. 729. Well, this is 27 squared. I bet it's 329, don't you?
7.
Or 729. I said 3 again. So I guess, could you take a number that you don't know and break it down into 2 numbers you do know? Like if I don't know 36 squared, do you? But what could I break it down to?
9.
Well, I'm adding. Couldn't you do... Well, you could do 6 and 30 because you should know 30 squared, shouldn't you? What's 30 squared? What's 20 squared, guys? 400. So 30 squared would be 900. 3 squared. 3 squared. Okay, so that one didn't work. Okay, 2 numbers that you would know better. What about 16 and 20? Should you know 16 plus 20? Should you know 16 squared and 20 squared? Yes. So you can break it down. This one would probably be more useful to me than the other one. But again, are you going to remember to use it unless you've used it a ton? No. Okay. Use the polynomial to factor. We multiplied, now we're going to factor. So what do you notice about the first one? 9m to the 4th minus 25n to the 6th. They're both perfect squares, and we have a difference, right? So we have the conjugate pairs that it's going to factor into. So what's it's going to factor to?
We would factor to 3m to squared.
So I'd put that in both of them, right?
Mm-hmm.
And one's plus and one's minus.
5n to the, 5n cubed. No.
Cubed.
Yeah.
So can that save you a lot of time? Unfortunately, they're not that easy, right? Okay, what about this one? Is 216 a perfect cube? Yeah, we're using, what is it?
Isn't it like 14?
14? Because 14 squared would be, 14 squared would end in a 6.
Yeah.
Times 14, that would end in a 4, wouldn't it? Not a 6?
Um,
We're looking for cubed, not squared.
okay. Um,
So you have to take a perfect square and then do it. So 9 wouldn't be right because that'd be 81 times 9 wouldn't give me a 6 at the back, right?
not the,
So 36 times 6 wouldn't give me, well, would it? 36. Well, you gotta do it. Because 6 times 6 would give me a 6. No, it wouldn't. Yeah, it would. Then carry a 3. So 36. And then 18 plus 3 is 21. So is 6 cubed 216. Is there a reason why you should know your cubes up to 20 or 10? So we figured out it's what? 6? Okay, so cube root of x cubed? X. Same sign? Minus. And the cube root is 216? 6. So now what?
x squared plus
Opposite sign. Good job.
6 squared. No.
6x.
Yeah.
Multiply. Plus 36.
Mm-hmm.
Okay, again, I'm not giving you any of these, but we'll do it. It's good for our brains to do things we don't like, right?
No.
So 11 cubed plus 5 cubed. Well, the cube root of 11 cubed is 11. Plus cube root of 5 cubed is 5. And then 11 is to be 121. Minus 55. Plus 25. So that gives me 16 times I get 151. Do you get 151? Because negative 55 plus 25, wouldn't that be 30?
Oh, yeah.
And then 30 plus 121 would be 151?
That's negative 30.
Yeah. So these two together, oh, it would give me negative 30, so I'd subtract, wouldn't I? I added. So they would be negative 30. So that would be 91 then, wouldn't it? Yeah. So then when I do something like this, would you not, I would multiply this by 10 and multiply it by 6 and combine the two. Do you guys ever do anything like that? No, you just do the math. I multiply by 10 because it's that easy to do. Yes? And multiplying by 6, I don't need to really write down. I can do it. So it's 5, 4, 6. So your answer is 6, 5, 4, 1.
What's the other 96 and 91 for?
I separated this into 10 and 6. I do it all the time. Like if you guys are working something and I say you do it and I'll do it, you'll see me write 9, 10 and then 546. I don't do the long multiplication process. I'm just weird. You guys want to do more? No? You think you're good? Okay. So most of these besides the cubes you could do without these rules, but the whole goal is to learn some of those rules to help you. Okay?